Kia ora, Year 12 and 13. This question is a classic calculus problem set in the context of Megan cycling from her home to school each day. And if you've got the Delta textbooks at school and the old Delta textbooks, in the extension exercises for one of the differentiation chapters, there's a bunch of classic calculus problems, and this is one of them. And what we've got here is we've got two different speeds at which we can travel, and we have to choose the best path. So she rides along a path from her home to somewhere along that path, point P, at a constant speed of 10 kilometres per hour, and then she cuts across a park. And so that's a more direct route to get to school at point S, but she can only go at 6 kilometres per hour. So where should she choose to do the cut across the park, right? So should she go like this, or should she go like this, or what? What we want to do here is to make her travel time a minimum, and that's the key to doing well in this problem, is we have to set up some kind of expression for the travel time. So when I do problems like this, I go really, really slow, and I always think about how long it takes me to drive from Wellington to Auckland. You can use horrible little formula triangles if you learnt those way back with distance, speed and time. I think they're just evil, so I always just start with a little equation, and I go, what is speed? And I can hear those of you doing physics just groaning at me down the laptop, but too bad, right? So speed is just distance over time, right? So if it's about 600 kilometres to Auckland, and it takes me about, 8 hours, that's how I get speed. So we don't want speed, we want time, right? So time is equal to distance over speed. And again, I can hear the laughter from those of you who find this stuff really, really easy, but it's very, very easy to screw up the setup of the problem and then to get a nonsense answer. So we're going to start by saying that this is what time is, and then we're going to work out what the distances are and what the speeds are in each case. And this time we're given the speed, so the speed part of it's going to be really easy. One's going to be 10 and one's going to be 6. So how can we set it up to find the distance? Well, we know that the total distance along the path is 4, right? So that whole distance is 4, and this is my crossover point here. Hopefully you can see straight away that we've got a baby right angle triangle in here. So I'm going to call the distance PQX, and that means that HP is the leftover, and that's going to be 4 minus X. So how far is she going to go? Well, first she's going to bike 4 minus X, and then she's going to bike this distance here. And finally, for the first time in all 3 papers, we've got some Pythagoras coming in, and the distance SP will be the square root of X. Oh, what happened there? Something weird just happened. Let me turn off ink to shape. So the distance that she's going to go here will be x squared plus 2 squared, which is 4. So now we can work out an expression for time, and our goal is to minimize that expression. So t for time is equal to the bit along the first bit where she can go 10 kilometers per hour. So 4 minus x over 10 plus this, x squared plus 4, but she goes more slowly here. And our goal is to find HP. So what we want to end up with here, we're going to get something for x, but the final answer is going to be 4 minus x. So just be careful that what we're answering is at what distance from her home should she choose to cut across the park. So that's what I'm looking for. And the question from here is reasonably straightforward, right? But we might do a wee bit of rewriting. We get 0.4 minus 0.1x plus 1/6 times x squared plus 4 to the power of a half. So that's t. I'm going to differentiate with respect to x to find a minimum, which is going to give me negative 0.1 plus, right, now chain rule carefully here, 1/6 times 1/2 of x squared plus 4 to the negative 1/2, and now differentiate your inside function, which is 2x. And we want that to equal 0 for a minimum. Right, so quite a bit of cleaning up to do. I'm going to put this back into being a fraction. I should never have worked with a decimal to start with. I've got negative 1/10 plus, right, well, I've got a 2 here and a 2 here, so we're going to have x over 6 root x squared plus 4 is equal to 0. Now, this looks bad, but it's actually not too bad at all. We've got x over 6 root x squared plus 4 is equal to 1/10. Cleaning that up gives me 10x is equal to 6 root x squared plus 4. And now you can see where we're heading is to some kind of a quadratic, but I need to square both sides. So squaring the left-hand side, I get 100x squared, and on the right-hand side, I get 36 times x squared plus 4. So it's a pretty easy quadratic. I've got 64x squared is equal to 2 times 72, 144. X squared is equal to, right, what have we got? 144 over 16, 144 over 64. So I can feel you reaching for your calculators. Simplifying that down, 16 is a common factor of both bits of the fraction. So x squared is equal to 9 over 4. Now, so x is equal to plus or minus 3 over 2, but x is going to be positive for a minimum. Now, I haven't proved that here. I haven't seen the schedule here, so I'm assuming they didn't need us to find that it's a minimum. That it's a minimum time taken. If they did need us to do that, we'd need to get the second derivative and show that the second derivative was positive. But I think it's pretty intuitive here that if we take the negative number, that actually does have meaning here. But that would be really weird, right? That would mean that she was going this way first, and then she was going all of that way to get to school. It doesn't really make any sense. I'm getting sidetracked. All you've got to say here, guys, is that x is equal to 3 over 2, right? And then that means that 4 minus x, which is the distance HP, is equal to 4 minus 2.5, which is 1.5 kilometers. And I think it's worth writing a sentence out like that. Hang on, what have I done? I've done something really stupid. X is 3 over 2. 3 over 2 is not 2.5. Okay. I'm trying to get to the end too fast. X is equal to 1.5. 4 minus x is equal to 2.5, not 1.5. So she should cut across the park when she is 2.5 kilometers from home. So there you go. I hope that's right. I think it's right. I'm sure someone from my class would have let me know by now if I'd made another mistake. But let me know any more requests. And Leo, I'm going to do your complex numbers one next. Thanks for watching.